This unit is going to focus on conversions within the SI system. So we're going to be looking at three different methods here to do those conversions. The first one is using the SI chart. The second one is proportional reasoning, and the third one is unit analysis. Now, we're going to be focusing on specifically proportional reasoning and unit analysis. Using the SI chart, though, definitely helps you if you were doing any science. And we're also going to be looking at, like I said, looking at conversions between the imperial and the SI, and then conversions involving square units and cubic units we're not responsible for. So really we're going to be looking at method 1 today, which again is not as important as method 2 or method 3. So this is the metric chart. They give us the main units used in the metric system with their relationship to 1 meter, 1 gram, or 1 liter. So kind of this is where your reference point is going to be. This is kind of where that's 1 meter, 1 gram, and 1 liter. So we're going to be expressing them gigameter or nanometers to the left and to the right in terms of meters. So they're just asking us here, a gigameter is how many meters? If you're going to the left, what you want to do is multiply. And if you're going from meter to, let's say, milliliter, you're going to have to divide. So here, 1 gigameter is how many meters? It is times 10 to the power of 9. So we're going to have 9 zeros here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Megameter, that's 10 to the 6 meters. So we're going to have 6 zeros here. 1, 2, 3, 4, 5, 6. 1 kilometer, that's 1,000 meters. Now we're going to go from 1 centimeter, which is right here, 2 meter. So again, we're going this way. We're going from meter to centimeter. So that's going to be 0.01 meters. 1 millimeter is how many? That's 0.001 millimeters. Micrometer, that's that right here, which is 10 to the negative 6, so 0.1, 2, 3, 4, 5, and 6. And nanometer is right here, is 10 to the negative 9. So that's 9 zeros, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1 liter is how many milliliters? So this is a liter right here. Milliliters is milliliters right here. So what we're doing is we're going from here to here. And so we're going to go ahead and multiply and say this is 1,000. 1 gram is how many milliliters? Sorry, 1 gram is how many milligrams, which is right here. That's going to be also 1,000. 1 kilogram is how many grams? That's also 1,000. Now to go from milliliter to liter, we're going to have to divide here and say this is 0.001. Milligram to gram is 0.001, and also 1 gram to kilogram, 0.001. Now, this is the first method, using the metric unit number line to convert. Again, you're not going to be asked to use this method. You will be asked to use this method 2 and 3, which is unit analysis and proportional reasoning, because sometimes you're not going to be provided with this table right here. But let's take a look at class example 1. They're saying that 1 meter is how many centimeters? So remember your meters here, you've got meters, grams, and liters, and you're figuring out to go from meters to centimeters. So again, here you want to multiply by 10 to the power of 2, so 1 meter is 100. Now you're going from millimeter, which is right here, to meters. So now you're going to go ahead and divide, and so this is going to be 10 to the negative 3, or 0.001 meter. 1 liter to milliliters is going to be 10 to the power of 3, which is 1,000 milliliter, right? This is your liter right here. You're going to milliliter, so again, you're going to multiply by 10 to the 3. So that means that if you're going from left to right, you are multiplying, and if you're going from right to left, you are dividing. Okay, let's take a look at class example 2. They want us to convert the following measures: 7.5 meters to centimeters. We know that 1 meter is 100 centimeters. So all I need to do is multiply 7.5 by 100. And so that means I'm going to get 750 centimeters. Milligrams to kilograms. I know that 1 milligram is going to be 10 to the negative 6 of kilograms. I'm going to have to go and move from milligrams, which is right here, to kilograms, which is right here. That's 1, 2, 3, 4, 5, 6. So times 10 to the negative 6. We're moving it 10 decimal places. So this is going to be 0.07235 kilograms. And the last one here, micrometer to nanometer. So this is your micrometer right here, and this is your nanometer right here. So you're going this way, so you're going to go ahead and multiply by 10 to the 1, 10 to the 2, and 10 to the 3. So this is going to be 325 times 10 to the power of 3, which is 325,000. Okay, class example 3 is saying they want us to convert the following and leave the answer in scientific notation. So here we're just going to leave it in scientific notation, or just leave it as the answer. We're not going to convert it to scientific notation. But if we're going from kilometers to millimeters, notice this is your kilometers right here, and this is your millimeters right here. So we're going this way, so we're going to multiply by 10 to the 1, 2, 3, 4, 5, 6. Right? Which is why this is going to be times 10 to the 6. This is nanograms to grams. So right here, all the way to grams is that 2, 3, 4, 5, 6. But now the other way around, so times 10 to the negative 6. So this is 580 times 10 to the negative 6. Grams, and this is millimeters. And then CL to capital ML, that's going to be times 10 to the negative 8, so 15,700 times 10 to the negative 8. Okay, let's add the unit for that one. The next method, which is the important method here, is proportional reasoning. Pretty much with proportional reasoning, you are setting up A over B equals C over D. So really you're looking at forming a fraction on one end, a fraction on the other, and putting them equal to each other. So let's take a look at class example 4. They say that Alice, Jim, and Rima were asked to convert 300 centimeters into meters. Part of their work is shown below. Each knew, right, and that's going to be using your formula sheet, that 1 meter is 100 centimeters. So that right there, you can express as a ratio totally on its own. 1 meter is 100 centimeters. And so when you lay out your other values here, you just make sure that you're consistent, that the numerator is meters and the denominator is centimeters. So here, let's take a look at what Alice did. She put the ratio 1 meter is 100 centimeters is equal to, we are trying to find how many meters is 300 centimeters. So we go x over 300, and then we isolate for x. So to isolate for x, what they did here was they multiplied both sides of the equation by 3. And so then they ended up getting that x is equal to 3, so 300 centimeters represents 3 meters. Now what Jim did was, same thing here, again multiplied both sides of the equation by 300, and then he got 300 equals x times 100, divide both sides of the equation by by 100, and you should get that x is equal to 3 meters as well. Same answer. And then Rima here on the other hand, instead of writing it as 1 meter over 100 centimeters, she wrote it as 100 centimeters over 1 meter, which is totally fine as long as your second part of the equation also sort of mimics the same pattern, where centimeters is on the top and meters is the one we are trying to find on the bottom. And then pretty much what Rima did here was cross multiplication. 100 times x is equal to 300 times 1, right? A over B equals C over D. That's A times D is equal to C times B, right? You can cross multiply. 300 times 1 divided by 100, that's 3 meters. So you can either do it this way or do it this way. In this way, what happens is the conversion is placed on one hand, and then the unknown and the other value that's given to the other is given here. In this case here, what's happened is that they set up the meters on their own and the centimeters on their own. So it doesn't matter. You can kind of have the centimeters set up this way. The meters set up this way and the centimeters set up that in the denominator. Or you can have on one side the meters and on the other side centimeters. Okay, let's take a look at class example 5. It says a photograph of an African elephant has a scale of 1 centimeters represents 0.6 meters. That automatically is your conversion. That's what you're going to be using. Okay, so I'm going to write that down. 1 centimeters over 0.6 meters is equal to. They're saying that the elephant's trunk in the photograph measures 3.5 centimeters. What is the actual length of the elephant's trunk? So again, make sure your centimeters are aligned. So this has to be in the numerator. And the actual length of the elephant in meters, we don't know. Okay, your final answer is going to be in meters. So now let's cross multiply. So this is just going to be x times 1 is equal to 0.6 times 3.5, right? That's times right here. So this is going to be x is equal to 3.5 times 0.6, which ends up being 2.1. And of course, make sure you express it in meters because that is the value that's being asked for us to find. Okay, class example 6 says, Reba followed a recipe for rice, bean, and soup and used 175 milliliters of beans and 650 milliliters of rice. That's going to be your conversion right here. 175 for your beans and 650 for your rice. Now, she's saying that she didn't have enough soup and added 70 ml to the beans. Again, you got to figure out where's your rice and where's your beans. Your numerator is beans and 650 is your rice. So that's going to be 70 milliliters in the beans and then x on the bottom. Cross multiply and solve for x. 175x is equal to 650 times 70 and divide both sides by 175. You'll get that x is equal to 260 milliliters. It pretty much means that if she adds an extra 70 ml of beans, she has to add 260 ml of rice so that the recipe works. Okay, and the last sort of method here is to use unit analysis, which is another method that you're going to be asked to find or use. Unit analysis pretty much means that what you want to do is multiply your value by the conversion rate. So we are being asked to convert from kilometers to meters. So 12 kilometers times. Now what you want to do is I pulled up a formula sheet for us here. It shows you that to go from kilometers to meters, you're going to have to go from kilometers to meters, we know that 1 kilometer is 1,000 meters, right? So that's our conversion. Now, in this case, because you want to convert to meters, you want to have your kilometers be on the bottom, so you can end up canceling out the unit divided by 1,000 meters. So your kilometers is going to cancel out, and you're left with 12,000, what's that, an extra zero, 12,000 meters. Again, if we're going from nanometers to meters, we know that 2730 nanometers here. We're going to multiply by the conversion. And when I multiply the conversion, again, the nanometers has to be on the bottom in order for them to cancel out. And I'm left with meters on the top. 1 meter is 10 to the 9 nanometers, and so 2730 divided by 10 to the 9 is going to be 0.000000273 meters. And that's pretty much what unit analysis is. Sometimes you're going to use more than one conversion in one calculation. Like for example here, you have 2.4 kilometers. We want to convert them to millimeters. So the first thing they did was convert kilometers to meters with this conversion right here. Again, making sure that the kilometers are on the bottom so they can cancel out. And then they went from meters to millimeters here, making sure the meters are on the bottom so you're left with millimeters. When you multiply all that out, you should get you should get 2,400,000 millimeters. Okay, class example 8 says convert 0.25 gigameters to megameters using unit analysis and known conversions involving meters. So here what you want to do first is convert it to meters. So usually want to go there, make sure your gigameter is on the bottom, meters is on the top. 1 gigameter is 10 to the 9 meters, and now I convert my meters to my megameter. So meters on the bottom so they can cancel. Megameters on the top, which is what I want to find. 1 megameter is 10 to the 6 meters, so you're left with 250 megameters. The last example here is Zimmer needs to convert 50 meters per second to kilometers per minute. So what you're going to actually have to do here is convert your meters to kilometers and convert your seconds to minutes. So meter to kilometer and seconds to minutes. So they want us to complete the work to solve the problem and show the cancellation units. So first things first here, they convert from meters to kilometers. 50 meters times the conversion. 1 kilometer we know is 1,000 meters, and they put the meters at the bottom so they are able to cancel out. Times second per minute, we know that 1 minute is 60 seconds. Multiply, of course here, the seconds are going to cancel out and you're left with the minute. So when you multiply the numerator together, 50 times 1 times 60 divided by 1,000, you should end up getting 3 kilometers per minute.